Hello everyone and welcome. I'm Sanjit from IBM. In this short video, you will see how to identify a query that's running slow due to a bad disk. There are many reasons a SQL statement can run slow. Netezza produces the blazing processing speed in combination of software and hardware components. Just like software issues, a bad hardware component can cause a query to run slow. Here is few common indication that can help you to identify if it's a hardware or software related problem. These are not a foolproof plan, but this can give you a basic starting point to investigate a query performance issue. Disk is the most moving component inside the Netezza appliances and most commonly the troublemaker. Here we will take a look how to identify if a SQL statement running slow due to a bad disk. Assume you have an update statement that used to take a few seconds to complete, but now it's taking very longer or not even completing. Let's go through some Netezza command and general purpose script to identify a possible disk issue that contributing a bad query performance. You can use user nz to run all the command mentioned here. nzresponders is a general purpose script that shows response of running queries across each data slice. This script provides similar information as nzsqa responders is, but in more user-friendly format. By default, this script runs in a loop. You can use Ctrl+C to interrupt it. You need to identify the response of your SQL statement in the nzresponders output. In case of a problem with disk, a SQL statement will be in running state for longer period. In general, if nzresponders constantly shows a particular data slice for one or more SQLs and you encounter performance problem, that indicate there could be some problem with that data slice. Here is an excerpt of nzresponders output. In this example, the update statement is running for some unusual period. The plan ID 83 is associated with the update statement. Few important things you need to consider here. The busy column shows number of data slices are busy running the query snippet. If the busy shows same as the total number of data slices in the system, it indicates things are running normally because query snippets running across all the data slices. The data slices column lists individual data slices number, those still running the query snippets. It can shows maximum 6 data slice number for a particular plan. Confirm the actual number of data slices with the value in the busy column. In this example, for plan ID 83, there is only one data slice in busy state, which is 13. Typically, I/O operation from data slice is fast, but if nzresponder shows any running SQL statement busy on certain data slice for long period, it indicates something may be wrong with that data slice. Alternatively, a data skewing can be manifest similar scenario, but that is a software related issues and can be verified using nzskew command. For sake of simplicity, assume you checked nzskew and there is no problem found. nzshow topology is another general purpose script provide a report that describes the overall disk topology. You can use this script to find out the actual disk associated with the data slice that you find out with the nzresponders earlier. Here you can see 1261 is the associated disk for data slice 13. The nzhw command allows you to manage the hardware on the Netezza system. You need to use show options and disk hardware ID with the nzhw command to find out the details information about the specified disk. Here you are using ID 1261 for disk hardware ID that you find out with the nzshow topology earlier. Here hardware ID 1261 is an active disk that located physically at SPA1, disk enclosure 2, disk slot 12. You can include the detail option for more information such as serial number, hardware version, and more details. The nzpush utility allows to perform different operation on spools. The disk smart options with nzpush provide disk status and show any read-write error with a specific disk. It will gather the SCSI disk smart statistics by querying the disk in the specified disk enclosure and slot. You need to run the disk smart option with appropriate SPA, enclosure, and slot information that found with the nzhw topology earlier. If you notice significant number of errors in the disk smart report, consider it as a problematic disk. For example, if non-medium error count greater than 30 or ground defect list higher than 300 are indication of a problem. Contact with IBM technical support to take appropriate actions with the disk. Hope this process will help you to identify a disk that can potentially cause performance issue. However, before going down to this path, perform checks to ensure performance issue is not caused by data skewing, and run NZ Health Check to confirm any other issues. Thank you for watching. Goodbye until next time.